Morgan, can you tell us a little bit more about why data plus smart manufacturing will indeed enhance performance and agility of this operation?
Of course. But let's first go into our boardroom. You're talking about performance. For the avoidance of any doubt, when you talk about performance, you're talking both about the performance of the operation and execution, as well as the performance of the plant itself, every machine, every robot, every resources. To achieve that, which is what you see now on the screen, we've made two breakthroughs. The first breakthrough is a technology breakthrough. We've built in all of the capabilities to manage the semantic of the product to be manufactured, to manage the MES data, and to manage at the same time all of the machine data, the whole of that in the same system. So in other words here, you're controlling IoT, relationship, semantic, all together. The second is more interesting. It's not technology. It's managerial. It's organizational. Analytics is not for executive, not only for executive. Indeed, analytics is for everyone in the company. Because what we want is we want to make sure that everyone is empowered to drive their everyday decision. But to do that, we need to give them the context. We need to guide them to make sure that when they're taking their decision, they understand the impact, and they're making sure that their decisions are geared towards enterprise performance drivers. So connecting performance with every decision.
Morgan, you just mentioned very briefly IoT. I'm a little surprised because in some other context, I mean, analysts are spending full session totally dedicated on IoT. So aren't we a little bit underplaying that?
That's a very good question indeed. Indeed, you're talking about performance. Performance requires availability of every system. If you want availability of every system, you need to control what's happening in real time. Here, more specifically, we are controlling the real-time data of our wind turbine, and you just seen that one has changed status. So, of course, I can go and see with the connectors to the OSI soft data, the real-time data. However, this is very, very far from being enough. Because in reality, if you take the IoT data alone, there is not much you can do. There is not much insight you can get. So at Dassault Systèmes, we believe, and we have the very strong belief, that IoT is a must, but under two conditions. Condition number one is we're using what we're learning on the virtual world to better interpret the IoT feeds. So there is no other way to get insight than to be capable of understanding how the system is behaving against the way it should have been behaving. This is how you get insights. This is how you identify weak signal. The second condition is that you actually project as well in the virtual world the whole of the context. What was the maintenance operation? What is the spares which are applicable? What is the nominal purpose for this specific system? So if you have both the context and if you learn from the virtual world, then IoT becomes of great value.
I really think you have a point here. I think one of the big differentiators of our approach is indeed the fact of being able to look at data in context. I mean, but I think this needs a little bit deepening.
Yeah, I can give you more insight on what I mean by context, and I realize I've been using the word a lot, and I'll continue to do that. But this is easy for me in your specific context, Guillaume. You have spent far too much time yourself in the factory to accept that people on the shop floor would agree to work just on a dashboard. Because if you want to give them context, you need to give them more context. So what you see now is a virtual representation of our factory with all of the real-time data fully projected here. So you have all of the performance KPI, you have all of the issues, you have all of the behavior. Everything is accessible from the virtual world. The good news is here you have all of the context. There is no more need to provide everyone with the name of the robot to make sure you speak about the same machine. It's obvious, it's in front of your eyes. And by the way, there is an interesting side effect to that. Because this is model-based, and because on top of our data science engine, we have a science engine with modeling and simulation, here we can play what-if scenarios to make sure we're configuring the system to behave the way we want and to model our future.
To the point. So if I understand well, here I'm going to manage my old data, right? So I'm going to be the king in my own castle within the four walls of my factory. But as industrial, we all know that this is not quite sufficient. We need to get open to the outside, and we need to get that data flowing in. How do we do that?
Yeah. I hope that I have not been misleading so far. It is true that in the last few minutes, I have mostly been showing you data that are coming from within the factory. But you're right. Smart manufacturing starts outside of the factory. And more specifically, start by capturing the data generated by the customers themselves. So what you now see on the screens are actually data generated by the customer on our excavators. So this is quality data, this is warranty data. And we've put lots of semantic to be able to match the specific issues to specific pieces of equipment of our excavators. But you know what is complex? What is complex is to connect the dots. To connect the dots between an issue and machine data. To connect the dots between MES and these issues. And to do that, we've made another breakthrough. We're using technologies that was initially developed for cyber criminality to connect the dots, which is what you see on the screen now. So here, this is where the analyst can build his knowledge graph, look at the incidents, connect the dots between all of the data. And while doing that, not only is solving his problem quicker, but at the same time, he's building a knowledge network. This is a capitalization system to make sure that this problem never happen again, one, and should that problem ever happen, that you get an alert immediately. So if I summarize, what we did show in the last few minutes, we did show how we're managing end-to-end performance, from execution to plant performance. We did show how we're using performance drivers and analytics to empower everyone in the factory, everyone in the shop floor, to make sure that every local decision is made geared toward performance. We did show how we're using IoT in our unique manner in the virtual world to get better insights. We did show how we're factoring into it all of the customer experience data. And then, of course, how we're using our science engine to model our future. The whole of that with a deep graph, a knowledge network to do investigation.